So class, today we're going to talk about percent composition by mass. Percent composition by mass is basically how much of each part is the whole made up of based on the mass of each part. For example, what percent by mass of a chocolate chip cookie is chocolate chips? If you're someone who really likes chocolate, you want a cookie that has a lot of chocolate chips in it. So you want a higher percent composition by mass of chocolate chips than of the cookie batter. So percent composition by mass is basically how much of a whole thing is made up of a specific part. But by how much, we're saying by mass. So our unit here is going to be a unit of mass. So the formula for percent composition by mass is the number of atoms of one element, for example, oxygen, times the molar mass of that element. Molar masses, remember we find those on the periodic table, divided by the molar mass of the compound, for example, water. And then we're going to multiply it by 100 to turn it into percent. Right, you always multiply by 100 to turn it into a percent. So let's do the example water. Okay? So let's find the percent of hydrogen in water and the percent of oxygen. Well, it seems like because there are two H's and one O, there's three things total, right? There's two H's and one O, so there's 3 atoms total. So it seems like it'd be 2/3 hydrogen and 1/3 oxygen. If there's 3 totals, we're talking about thirds, so 2/3 hydrogen and 1/3 oxygen. But that's just the percent of each element. But we want to know the percent composition by mass. And that's going to be different than 2/3 and 1/3 because oxygen and hydrogen have very different masses. So let's see how this works. Let's find the percent hydrogen. Okay, and then we're going to find the percent oxygen. So, the percent hydrogen, okay, well, we need the number of atoms, so looking up here, the number of atoms of that element. So in this case, the number of atoms of hydrogen. So we have 2 atoms of hydrogen because of this subscript 2, times the molar mass of the element. You'll see from the periodic table, the molar mass of hydrogen is 1.01 grams per mole. And now we need to divide by the molar mass of the compound. Well, the molar mass of the compound, we need to add up the molar masses of these. So we need 2 hydrogens and 1 oxygen. And we add those up, we should get 18.02 grams per mole. Because hydrogen's 1.01 and oxygen's 16. And that should add up to 18.02 grams per mole when we consider the fact that there are 2 hydrogens. Now we multiply that by 100 to turn it into a percent, and we should get 11.2% hydrogen. So water is 11.2% hydrogen. Okay? Now let's figure out oxygen. Number of atoms of one element, well, there's 1 oxygen here, times the molar mass. Its molar mass from the periodic table is 16.00 grams per mole, divided by the molar mass of the element. Now that is 18.02. It's the same as what we used above, grams per mole. We multiply that by 100 to turn it into percent, and we should get 88.79% oxygen. Okay? Now, there are 2 ways to find that percent of oxygen. The way that I did it was I used this formula from up above. Okay? Now, let's think of the other way to do it. Water contains only 2 things, oxygen and hydrogen. I already found out the percent hydrogen. So the other way to find the percent of oxygen is to take 100% and then subtract the percent of hydrogen, which is 11.2%. That's our percent hydrogen, and then that will give us 88.8%. And that's our percent of oxygen. Notice that that is very similar to 88.79, just a difference of sig figs. So that is the other way to find the percent of the other part, which in this case is oxygen. So class, now I have 3 example problems. Here is the first one for you. You have CH3OH, which is methanol, and you are going to find the percent composition by mass of each element. So what percent is carbon, what percent is hydrogen, and what percent is oxygen. So pause the video now and work on that, and then I will show you the answers. Okay, pause now. Okay class, here is the answer. Your percent carbon, you have 1 carbon, you multiply that by the molar mass, which is 12.01, and then divide it by the molar mass of the whole compound, and then you get 37.5 after you multiply it by 100. 37.5% carbon. Percent hydrogen, there's 4. Notice that. There's 3 H's here, but then there's 1 H there. Okay, big common mistake. So there's 4 hydrogens. Multiply that by the molar mass, 1.01, divided by the molar mass of methanol. Multiply by 100, you get 12.6% hydrogen. And the percent oxygen, there's 1 of those, multiplied by its molar mass, 16, divided by the molar mass of methanol, which is 32.05, and then multiply by 100, and you get 49.9% oxygen. And you'll notice that when you add these up, these all do add up to 100%. Now that's not always the case. That's not always the case because of sig figs. They can be a little bit off. And sig figs are hard on this. Generally I go to about 3 sig figs. So they don't always add up to 100 based on your rounding, but it should be very, very close. Now, again, another way you could have found oxygen, or whichever the last element was that you did, was to add up the other 2, subtract them from 100, and then you should get the amount of oxygen. So either way would be correct. So here, class, is your second example. We are going to work with acetaminophen, which is the active ingredient in things like Tylenol. It's a pain reliever and fever reducer. The formula for acetaminophen is C8H9NO2, and you're going to find the mass percent of each element. I just wanted to throw new terms at you. This is another way to ask the percent composition by mass of each element. Same thing as mass percent of each element. So pause it now and find the percent carbon, percent hydrogen, percent nitrogen, and percent oxygen in acetaminophen. So pause it now. So here, class, is the answer. Our percent carbon is 63.55%. Our percent hydrogen is 6.01%. Our percent nitrogen is 9.267%. And our percent oxygen is 21.17%. And you'll notice if you add these up, you get 99.997%, obviously really close to 100%. It just has to do with rounding. So if you found oxygen by adding these up, or if you found your last element by adding up the other 3 and subtracting from 100, you would have gotten a slightly different answer for oxygen or for one of the others, but that is okay. So class, here is your last example. Find the percent composition by mass of each element in aluminum sulfate. So first of all, it really helps to know what aluminum sulfate is. And I know it's been a little while, but let's try to work on that. We see aluminum on the periodic table is Al, right? Now let's think about what charge aluminum has. You should have written this on your periodic table. Okay, think about it. Aluminum has a charge of 3+. Now sulfate, you should have memorized this one. It is SO4 2-. So let's think about this. If we have a charge of +3 and a charge of -2, how do we put those together? What is our least common multiple? And hopefully you figured it out that that would be 6. So how do we get 3 to make 6? We need 2 of them. And how do we get 2 to make 6? Well, we need 3 of those. So we end up having Al2, and then parentheses, because it's polyatomic, SO4 3. So now that we know that the compound is Al2 SO4 3, please figure out the percent composition by mass of each element, so of aluminum, sulfur, and oxygen. in aluminum sulfate. Now you're going to need to be careful and think about how this 3 distributes to the sulfur and the oxygen to figure out how many of each element you have. So pause it now and figure out the problem. So class, here are our answers. We have aluminum, which is 15.77%. You had to know that there were 2 aluminums, then that's the molar mass of aluminum from the periodic table. And then you had to add up the molar masses of the whole thing. And if you did not get 342.17, then you would not have gotten any of this problem correct. So let's think about that. That comes from 2 aluminums, 3 sulfurs, and 12 oxygens. Right? There's 3 sulfates, so that must be 3 sulfurs and 12 oxygen. Draw pictures of sulfate if you need to. Okay, and that adds up to 342.17 grams per mole. So our percent sulfur, we've got, as we said, 3 of these times its molar mass divided by the molar mass of the compound, and we get 28.12% sulfur. Now for oxygen, we take 12, because 4 times 3 is 12 oxygens, times its molar mass divided by the molar mass of the compound, and we get 56.11% oxygen. Nice job. So class, the last thing to talk about, which will prep us for the next class, is to talk about empirical formulas. Now empirical formulas, that's the simplest ratio of atoms or moles. It's the simplest ratio of atoms or moles. So if this class has 6 boys in it and 6 girls, the simplest ratio would be 1 boy to 1 girl. If it was 12 boys and 6 girls, the simplest ratio would be 2 to 1, 2 boys to 1 girl. So we're just going to talk about the simplest ratio of atoms or moles. So for example, if I have the molecular formula C6H6, okay, this will be example 1, C6H6. What is our empirical formula? If we have 6 C's and 6 H's, what's the simplest ratio? Hopefully you can figure that out. That's 1 C and 1 H, okay, which we just write CH, right? The ones are invisible. Again, the simplest ratio of 6 to 6 is 1 to 1, so 1 C and 1 H. Now let's remember that these subscripts here, okay, and the invisible ones here, they represent the number of atoms or moles. So we're talking about simplest ratio of atoms or moles of atoms. Let's do a second example. Let's have C2H2. Okay? Try to figure out what's the empirical formula. What's the simplest ratio of C2H2? Hopefully you figure that out. That also is CH. Okay? So notice, 2 totally different molecules here can have the same empirical formula. Right? C12H12 would also have the empirical formula CH. So very possible to have the same empirical formula but to be different molecules. Let's do a third example, C2H4, and a fourth example, H2O. So think about that. C2H4, what would be the simplest ratio of C's to H's? Hopefully you got that. The simplest ratio of 2 to 4 is 1 to 2. So it's CH2. Now H2O. Remember that we have an invisible 1 right here. So what's the simplest ratio of 2 to 1? Well, it is 2 to 1. So you wouldn't say it has no empirical formula. Everything has an empirical formula. You would just say the empirical formula is H2O. So notice, those are the same things. And that's okay. The molecular formula can be the same as the empirical formula if that is the simplest ratio. So the empirical formula of H2O is H2O. Nice job today, class. We'll see you next class.